The last set of notes for Section 1 of Chapter 2 cover the idea of even and odd functions. Now we say a function is even if f evaluated at negative x equals the function value f evaluated at x for all possible values of x in the domain of the function. An odd function is any function where f of negative x equals negative f of x for all values of x in the domain. Here's a hint. Don't just base the definition on a single point. This is actually true for all possible values of x in the domain, and we don't necessarily check every possible answer, but we start by checking one and then at least one other. So you want to check at least two different values before you start thinking that a function, f or g or whatever, can be even or odd. For example 1, let's consider the parabola defined by y equals x squared plus 1. So if we graph this function out, you can see that it goes down and then back up. So it sort of looks like it would hold water. It's a parabola that opens upward up the y-axis. Now, is this an even or is this an odd or is it neither type of function? Well, let's take some values. So algebraically, let's consider the value negative 1. Okay. So f at negative 1 would be what? So I'm going to plug negative 1 squared would be positive 1 plus 1 would be 2. What about f evaluated at positive 1? Well, f evaluated at positive 1 would be 1 squared, which is 1, plus 1, which is 2. So what we see is that f of negative 1 equals 2 and f of positive 1 equals 2. So whether we're at negative 1, we get 2, or at positive 1, we get 2 for the y value. What about negative 4 and positive 4? Well, if we plug negative 4 into our equation, negative 4 squared is 16, plus 1 is 17. Okay, what about 4? 4 squared is 16 plus 1 is 17. So again, at negative 4, we would get positive 17, and at positive 4, we also would get the same thing. So algebraically, what we're seeing is that whether I put a negative or a positive number in, as long as the magnitude or the number part is the same, I get the same result out. Notice that this graph is symmetric about the y-axis. And this actually is an even function. If you take the part to the left of the y-axis and you could fold this graph on the y-axis and flip it over to the positive side, the left and the right side would line up right on top of each other. That's your definition of symmetry across the y-axis, is that if you fold about the y-axis, the graph would line up on top of itself. Now let's consider another function. How about the line f of x equals 5x? So you're familiar with the equations of lines. We reviewed those in Chapter 1. So what about a line? Is it even? Is it odd? Let's consider a couple of function values. Let's start at negative 2. So if we start at negative 2 and we take 5 times negative 2, we get negative 10. Okay. What if we get f evaluated at positive 2? So now we're evaluating at 2, so 5 times 2 would be positive 10. So what we see is that f of negative 2 is negative 10, f of positive 2 is 10. So f of negative 2 equals negative f of 2. Okay, because negative 10 equals negative of 10, right? What about f of negative 4? F of negative 4 is down here at negative 20. 5 times negative 4 is negative 20. And then f evaluated at 4 is going to be 20. So we see that 1 is negative 1 times the other. So we meet the definition of f of negative x equals negative 1 times f of x. So f of negative 2 equals negative f of 2, and f of negative 4 equals negative f of 4. Or in more generality, f of negative x equals negative f of x. So this meets the definition of an odd function. Notice if you take the part of the graph in the first quadrant, so if you think of the axes as dividing into four rectangular regions, or what we call quadrants, the top right one is the first quadrant, the top left is the second, the bottom left is the third, the bottom right is the fourth. So we sort of count 1, 2, 3, 4 in a counterclockwise direction. Well, if you take the part in the upper right-hand section of the graph, so that's your first quadrant, and you rotate it 180 degrees, okay, then what you end up with is the exact graph that's in the other part, that's in the third quadrant, okay. So let me show you a couple of rotated views here, okay. So I'm going to actually increase this so we can see these. Okay, so what we're going to do is take the part in the first quadrant here and we're going to rotate it. Okay, so after I rotate it just 1/4 of a turn, or 90 degrees, notice the y-axis is now going side to side here and the x-axis has been rotated here. Now let's rotate it another 90 degrees. Now the y-axis is positive down here, notice. And so we've taken this top graph and we've just turned it half of a rotation. So if this, where the positive 25 was at the top of our desk, now the positive 25 is at the bottom of our desk, or it's facing us now. But notice this line is exactly what was in the third quadrant when we started. Here the yellow line is in the first quadrant. Okay, and basically what we're doing is we're saying that it will produce this purple line that's in this third quadrant when we rotate it 180 degrees. Okay, so that's how you can check for odd functions, is if you rotate one graph 180 degrees, does it produce the other graph? And if it does, then you've got an odd function. Now let's consider the function f of x equals x cubed minus 3x. Okay, the function is the entire graph, both the purple and the yellow sections that I have listed here. Okay, so let me zoom down a little bit so we can get the whole graph in here. But what it does is it starts near sort of large magnitude but negative numbers, or negative infinity. It increases, then it goes down, and then it goes back up. Well, what would happen if I took this piece of paper and I rotated it 180 degrees? Well, this yellow part would rotate to where the purple part is. So again, this would be an odd function. And what you may want to do is print this out and just rotate it and see what happens when you do that on that piece of paper. So if you rotate a graph 180 degrees, okay, and sort of the one part takes and lies on top of the other part, okay, or you don't really have a change in the graph, then we say it's symmetric about the origin. Now that defines what's going to be an odd graph. So if you take this, rotate it 180 degrees, you would get this purple part. So that is the definition, both visually, okay, with the rotations and symmetry about the y-axis, or algebraically when we actually plug numbers in and checked, of how you indicate whether functions are even functions or odd functions.